Right now, without you feeling a single thing, you are moving at over 1,600 kilometers per hour. Not in a car, not on a plane, just standing there, reading the sentence. That's how fast the surface of the Earth spins at the equator. You've never felt it, never noticed it, never once had to brace yourself against it. It's just always been true. But what if it stopped? Not slowed down, not wobbled a little, stopped completely, and let's say, for the sake of the thought experiment, over the course of one single day. The answer isn't an ice age, it isn't a flood, and it definitely isn't what most disaster movies show you. It's stranger than that, and it starts with a problem most people never even think about. Momentum doesn't care about people. Here's the part almost every what if video skips. You are not glued to the Earth. You're standing on it, held down by gravity, but you and the atmosphere and the oceans are all moving with the planet at that same 1,600 kilometers per hour at the equator, purely because of momentum. The same reason you fly forward when a car slams the brakes. If the Earth stopped spinning instantly, nothing attached to the surface would stop with it. Not you, not the oceans, not the air. Buildings, mountains, entire continents would keep moving at highway jet speeds while the ground beneath them simply isn't moving anymore. The result isn't a bad day. It's a planet-wide catastrophe measured in minutes, not months. Oceans would rip away from their basins. The atmosphere itself, the air you're breathing right now, would keep traveling at 1,600 kilometers per hour, scouring the surface like a global sandstorm made of wind alone. That's the instant version. It's also, physically, almost impossible. Nothing in nature stops a planet on a dime. So let's ask the more interesting question, the one scientists actually study. What if it slowed down gradually over years or centuries until it eventually stopped? That version doesn't kill everyone in an afternoon. It kills the world we know in a much slower, much stranger way. A spinning Earth is the only reason you get a sunrise and a sunset. Stop the spin, and one thing happens immediately. The 24-hour day disappears. In its place, you get something closer to the moon's relationship with Earth. A day that lasts as long as it takes the planet to complete one orbit around the sun. That's not 24 hours anymore. That's a full year. Half the planet would face the sun for 6 straight months. The other half would sit in darkness for 6 months at a time. Picture the side facing the sun. No clouds rolling in to cool things down at night, because there is no night. Just sun, for months, baking the same patch of ground over and over. Temperatures on that side could climb past 60 degrees Celsius, 140 degrees Fahrenheit, turning entire regions uninhabitable. Deserts would spread. Rivers would evaporate before they could reach the sea. Now picture the other side. 6 months of uninterrupted darkness. No sunlight means no warmth. Temperatures could plunge below minus 40 degrees Celsius, minus 40 degrees Fahrenheit, locking oceans in ice and turning fertile land into frozen wasteland. Only one place on Earth would stay survivable in the way we understand it now. A thin ring near the Terminator line. The boundary between permanent day and permanent night, where the temperature might land somewhere livable. Everyone who survives would be squeezed into that ring, fighting for a strip of land that never really existed before. Here's the part that surprises most people, because it has nothing to do with sunlight at all. Earth's rotation isn't just about day and night. It's the engine behind the magnetic field that protects us. Deep inside the planet, molten iron churns and swirls because the Earth spins. That churning motion generates what's called the geodynamo, and the geodynamo is what produces Earth's magnetic field. Stop the spin, and over time, that engine sputters out. Without a strong magnetic field, Earth loses its shield against the solar wind, the constant stream of charged particles blasting out from the sun. Right now, that field deflects most of it, funneling the rest toward the poles where it puts on a show we call the aurora. Without the shield, the atmosphere itself starts getting stripped away, slowly, particle by particle, the same way scientists believe it happened to Mars billions of years ago. Radiation levels at the surface would climb, cancer rates would rise, sensitive electronics, satellites, power grids, anything depending on stable electromagnetic conditions, would become far less reliable. It's a strange kind of danger because you wouldn't see it happening. No storm, no fire, no flood. Just an invisible shield quietly switching itself off, 1 degree of rotation at a time. There's one more piece of this most people never expect, and it's written directly into the shape of the planet. Earth isn't a perfect sphere. Because it spins, centrifugal force pushes mass outward at the equator, giving the planet a very slight bulge, about 21 kilometers wider around the middle than pole to pole. The oceans follow that same bulge. If the spin disappeared, that bulge would disappear with it. All that ocean water piled up around the equator would have nowhere to stay. Gravity would pull it toward the poles instead, reshaping it into two enormous polar seas. Coastal cities near the equator, places like Singapore, Nairobi, Quito, would watch the ocean recede for what might look at first like good news. Meanwhile, regions near the poles, many of them currently frozen or lightly populated, would slowly disappear underwater as a new ocean rose to claim them. It wouldn't happen in a single tidal wave. It would happen over generations, an entire redrawing of the map so slow that a person could stand on a beach their entire life and never quite notice the water was retreating, until their grandchildren's grandchildren found nothing but dry land where the coastline used to be. So, picture the finished version of this world, a thin ring of survivable land circling the planet, caught between a sun-scorched hemisphere and a frozen one, a magnetic field too weak to fully protect the people living there. Oceans reshaped into two vast polar seas, and the equator, once humanity's most crowded, fertile band of the planet, turned dry and empty. Life wouldn't vanish. Life is stubborn. Somewhere in that narrow twilight ring, something would almost certainly adapt, the same way life has adapted to hydrothermal vents, Antarctic ice, and the driest deserts on Earth today. But it wouldn't be this world, not even close. Here's the strange part to sit with. Every sunrise you've ever seen, every single one, only exists because a giant rock, floating in empty space, happens to be spinning. Nobody's holding it in place. Nothing is pushing it along, it's just been turning quietly for about 4.5 billion years, and it's slowing down by roughly 1.7 milliseconds per century, so slightly you will never live to notice. That spin gives you morning and night. It gives you a magnetic field that lets satellites work and keeps radiation off your skin. It gives you an ocean shaped exactly the way it needs to be for the coastline you grew up next to. You've never had to think about any of it. It just works. Has always worked. Will keep working long after you're gone. Maybe that's the real answer to what if the Earth stopped spinning? It's not really a question about disaster. It's a reminder that the most ordinary thing about your entire life, waking up, watching the sun move across the sky, going to sleep, is actually one of the most improbable, most fragile arrangements in the entire solar system. And tomorrow, when the sun comes up again exactly on schedule, maybe that's worth noticing.